section 3.2, graphing linear equations using intercepts. Okay, blank of a line is the point where the line crosses the x-axis. Where it crosses the x-axis, we'll call the x-intercept. And the y-coordinate of the x-intercept is, well, let's look at an example real quick. If I have a line and I'm looking at the x-intercept is going to be the point where the line crosses the x-axis. This point has no height, so the y-coordinate would be 0. It's not up or down at all on the y-axis, in the y direction, so the y-coordinate of any x-intercept should be 0. Similarly, if I'm looking at the place where a line crosses the y-axis, it'll be the y-intercept. Okay. And similarly, like we talked about the y-coordinate of the x-intercept, we can talk about the x-coordinate of the y-intercept. So if we draw another line, let me draw a better line. There we go. Let's talk about the y-intercept. Right there, I'm crossing the y-axis, and the x-intercept. X is right there at the center. It's not over left or over right. It's right in the middle, so the x-coordinate is 0. So if it's an x-intercept, the y-coordinate is 0. If it's a y-intercept, the x-coordinate is 0. Let's use this graph here to identify the intercepts. In part A, we're looking for the x-intercept. So that's the place where my line crosses the x-axis. It's going to be right here. Intercepts, or any ordered pair, is going to be labeled by listing the x and y coordinates. So this is going to be the ordered pair 2, 0. Like we said, the y coordinate would be 0, and the x coordinate on this one happens to be 2. The y-intercept, where does our line cross the y-axis? The x coordinate of that is 0, and the y coordinate of this particular one is -1. Okay. Part C and D just asks us for 2 other points. Find y when x is -6, or +6, my bad. So when x is +6, y is 2. So I can write y equals 2, or I could write the ordered pair 6, 2. And find x when y is -4. So -4 is a y reading now. We're going to find the x value. So right there. And so that one is going to be the ordered pair -6, 4. -4. Or an answer to the question, we're looking to find the x, so we could just list the x value as -6. Alright, let's look at the next one. Does the graph of a linear equation in 2 variables, a line, always have an x and a y-intercept? Interesting question. So I've got my x and y axis here. If I draw a line like this, yeah, it's got an x-intercept and a y-intercept, but is that always the case? What if my line, need to draw a little better, what if my line went like this? Does it still have an x and a y-intercept? Yes, they both happen to be at the same point right here. It's crossing both axes at the origin. So far I've got yes, it has both. But what if I drew a horizontal line? A horizontal line has a y-intercept but no x-intercept, right? If you think about it, there's another type of line I could draw that's going to have no y-intercept. If I drew a vertical line, there's going to be no y-intercept. So does a graph always have to have both? Well, if it's a regular line that has a diagonal direction, then yes. But if it's horizontal or vertical, then no, it's not going to have necessarily both. It's going to have one or the other, though, for sure. There's no way I can draw a line that has neither. Alright, objective 2. Graphing a linear equation in 2 variables using the intercepts. So first of all, we need to find the intercepts. So let's talk about finding the x-intercept, and then we'll find the y-intercept. Now, for the x-intercept, we already said we know that the x-intercept has the property that y is equal to 0, so we're going to go ahead and plug 0 in for y to find that x-intercept. So I'm going to start with 2x plus 5 times 0 equals 20. So 2x plus 0 equals 20. 2x is 20. If I divide both sides by 2, I know that x is 10. So the intercept is 10, 0. That would be the x-intercept. Intercept should be written as ordered pairs. I already knew the y-coordinate was 0, and I found the x-coordinate was 10. Let's try to find the y-intercept. I know, since it's a y-intercept, that x is 0. So let's go ahead and plug 0 in for x. So that's 2 times 0 plus 5 times y equals 20. So 2 times 0 is 0, so I know that 5y equals 20. And if I divide both sides by 5, I get that y equals 4. So the ordered pair here is 0, 4, and that would be my y-intercept. I already knew that the x value was 0, and I found that the y value was 4. Okay. If I would have read a little bit more on this problem, I knew I was going to find the x and y intercept. I didn't pay much attention to the fact that I was asked just to find the x-intercept in the first example and to find the y-intercept in the second example. So I got a little bit carried away right there. Okay, let's go to the next page. Alright, this is a different equation right here, and when I find the intercepts, this time I'm going to use them to graph this equation. So we're going to go through and find them again. So let's just find the x-intercept. And to do that, we know we're going to use y equals 0. So it's going to give us 6x minus 9 times 0 for y equals 18, or 6x equals 18. Divide by 6, x is 3. So the x-intercept is 3, 0. 3, 0 is right here. Let's also find the y-intercept. The y-intercept will have x equal to 0. So that's 6 times 0 minus 9 times y equals 18. So I've got negative 9y equals 18. And so if I divide both sides by negative 9, y is negative 2. So the intercept is 0 for x, negative 2 for y. Sorry, that one's a little bit sloppy. 0, negative 2, so it's ordered pair right here. And I can connect those to find the equation, or to draw the equation of this line. Okay, it's usually easier to connect if I have more than 2 points, but I can do it with 2 points. 2 is the very, very minimum I need to draw the equation of a line. Okay, intercepts are good points if you're going to use just 2. It's nice to have the intercepts. You can see where your line crosses an axis. It helps you line them up better. But again, that was just the minimum I would absolutely require to draw on a line. Okay, we're going to graph the next problem by finding intercepts as well. So let's start with finding the x-intercept. I know if I'm looking for an x-intercept, that means that the y is going to be 0. So I have x plus 2 times 0 equals 0. So x is equal to 0. Okay, so this is the ordered pair 0, 0. And if I find the y-intercept, that's where x is equal to 0. So 0 plus 2y equals 0. So 2y equals 0. And if I divide both sides by 2, y equals 0. So the y-intercept is 0, 0. So that's the same point. That's not enough information to draw a line. I need to have 2 distinct points. So regardless of the directions, I have to go ahead and find a third point. My equation was x plus 2y equals 0. We've already found that 0, 0 is an ordered pair. I'm going to go ahead and plug any number I want in for x or for y. I'm going to go ahead and try 4. Just any number. So let's say 4 is my x value. Let's figure out what the y value would need to be. So for y, so we're going to subtract 4 from both sides. 2y equals negative 4. Divide by 2. Y equals negative 2. Okay, so this ordered pair would be 4, negative 2. Let's go back up and graph that one. 4, negative 2, and again right now I have the bare minimum that I would need to draw the equation of the line. So let me go ahead and connect those. And I've got my line. It's very important to make sure that your line goes across the entire graph right here. I don't want something short. I had to draw mine in 2 places because I'm using this weird computer tool, but a ruler would be really helpful right there. And if you're more comfortable, get a 3rd point. Like 2 is not a magic number. I mean, usually we'll go with 3. 2 is just the bare minimum number of points that I would need to be able to draw a line. Let's go to the next page. Okay, so the next objective is about horizontal and vertical lines. How would I graph something like x equals negative 2? So first of all, what do you know about x equals negative 2? Well, I know x is negative 2, but I don't know anything about y. It's kind of nice because there are no restrictions on y. Y could be 4, or it could be 8, or it could be negative 1. It has no restriction. The only thing that matters is that x remains negative 2. That's my equation. X is negative 2. So any of these points with x equals negative 2, whether they have a y value of 4, or a y value of 8, or a y value of negative 1, they're all true. So this equation is going to turn out looking like a vertical line through negative 2. Okay, let's check out the next one. Y equals 1. Very, very similar. If I'm thinking about my x and y values, I know that y is 1. I've got no information about x. So x could be anything. It could be 5, or it could be negative 1, or it could be 3, as long as y is 1. So let's graph those ordered pairs. The first one was at 5, 1. The next one's at negative 1, 1. And the last one we picked was at 3, 1. And then we'll go ahead and connect them. So we can see that they're all going to be on that horizontal line with that height y equals 1. Okay. So our summary right here says that if a and b are constants, the graph of y equals b, if I have y equals, we see that it's going to form a horizontal line. And a horizontal line is going to have a y-intercept, and the y-intercept will be the only possible y value, which is b. For the next one, x equals a, we saw already that x equals a was going to be a vertical line. It's vertical. And the x-intercept of that vertical line is going to be, again, the only possible x value, whatever the x value is in the equation. So if it's x equals a, the x-intercept is going to be at a. Now let's go ahead and write the ordered pairs for those. Intercepts aren't just single numbers. So the ordered pair for the y-intercept, since it's a y-intercept, that was the y-coordinate, so it would be 0, b. And for the x-intercept, since that's an x value, the ordered pair would be a, 0. Okay, and that's the end of the section.